Hey everyone, this is the Algebra 1 Unit 3 practice test. So I'm just going to go through and work these problems and show you how I would solve them. So let's get right into it. So this is question number 1. We're talking about systems of equations here. So just a quick review, right? A system of equations are, we're looking at linear equations, right? So two lines and the solution represents where those lines cross. Okay, so if we were to graph a system of equations, the solution would be where the two lines cross. In order for something to be a solution, that point has to be on both lines. So for question 1, they give us these two equations, 5x plus 7y equals 39, and they give us negative x plus 2y is equal to negative 1. And then they give us this point 5, 2, and they want to know if this is a solution. So in order to be a solution to this system, the points 5 and 2 would have to be on both of these lines. So the way that I check that is I just plug 5 and 2 in for x and y, and then see if they're true. So this would be 5 times 5 plus 7 times 2, and that should equal 39. So it's going to be 25 plus 14 is 39, and that is true. Do the same thing here, plug in x and y. So I get negative 5 plus 2 times my y value is 2 is equal to negative 1. And so I get negative 5 plus 4 is equal to negative 1. That is also true. Okay, so since both of those are true, the point 52 is a solution. So point 52 is a solution. Okay, so this would be a true statement. Question number 2, they ask you to solve the system of equations by graphing. And so I'm just going to graph each one of these lines. So number 2, so we've got y is equal to negative x, and y is equal to negative 2x minus 1. So for this one, my slope is negative 1. And my y-intercept is 0. Okay, so first line, it crosses the y-axis at 0 and has a slope of negative 1. Okay, so it goes down 1 and to the right 1. So there's the first line. The second line has a slope of negative 2 and has a y-intercept of negative 1. So my second line crosses the y-axis at negative 1 and has a slope of negative 2. So it's going to go down 2 and over 1. Okay, slope of negative 2, slope of negative 1, and then I need to show where that crosses there. So my solution to this system of equations would be negative 1, 1. Okay, so my solution here is going to be negative 1, 1, the solution. So they give us a system of equations here, and there's a couple of parts to this. So first of all, 4x plus 3y equals 0. So 4x plus 3y equals 0. And then we have 3x minus y equals 5. Okay, and they want to know where the solution to that is. And so if I look right here, it's this point right here, and so that's a little hard to read. If I look here, each one of these is going over by 2. So this is 1, 2, 3. So this is negative 3. Negative 3. And then my y value is 4. So number 3, I'd have a solution. Negative 3, 4. Okay? And so this is for the system. 4x plus 3y equals 0. And negative 3x minus y is equal to 5. Okay, so we can put that solution in, so negative 3, 4. And then the last part, they ask you to match the graphs to the equations. Okay, so the red one is A and the blue one is B, and so I have to figure out which one is which. So a nice way to do that would be if I had one of these in slope-intercept form. So if I had it in the form of y equals mx plus b, then I could do that, pretty easily. So I'm going to look at this equation right here because it is pretty close to y equals mx plus b. So to get it into that, I'm going to add 3x to both sides. And so I've got negative y is equal to 3x plus 5. And then I'm going to multiply everything by negative 1. And that's going to give me positive y is equal to negative 3x minus 5. So that tells me that this second equation here, right, crosses the y-axis at negative 5 and has a slope of negative 3. Well, if I look at these two lines, line B crosses the y-axis at negative 5. And it's also got a slope of negative 3. Okay, and I can tell that by looking at the values here. So it crosses here, it goes down 1, 2, 3, and over 1. Okay, so it's got a slope of negative 3. So B is going to be the second one. The second one's going to be graph B, and the first one is going to be then graph A. Okay, so number 4, same thing here, y equals 2x plus 11, and y equals negative x minus 1. So we're asked to graph these, so this has a slope of 2 and a y-intercept of 11. And then this one has a slope of negative 1 and has a y-intercept of negative 1. Now, when I go to graph this first line, I'm going to run into an issue because to graph that, I need to cross the y-axis at 11, and I can't do that. It runs off my graph. Okay, so what I need to do is I need to come up with maybe a different point that I can use. And so what I'm going to do is I'm going to build a little table of values here for my first equation. So this is x, and this is 2x plus 11. And so I know that if I put in 0, I get 11. But if I put in, let's try negative 2 and see if that works. So that's going to be negative 2 times 2 is going to be negative 4, plus 11 is going to be 7. Okay, so that's still off my graph. Let's try negative 3. So if I put in negative 3, I'd get 2 times negative 3 is negative 6, plus 11 is going to be 5. So negative 3, 5. So that's a point that I can use. Okay. So I can't use the y-intercept because it runs off my graph, but I can use the point negative 3, 5. So negative 3, 5, negative 3, 5. Okay. So there's one point. And then it's got a slope of 2. So if I tried to go up 2, again, I'm going to run off my graph, but I can also go down 2 and go this way. So I can see between those 2 points, right? That's going to have a slope of 2. My other equation here crosses the y-axis at negative 1 and has a slope of negative 1. So it's going to go right through here. And so I can see my solution then, and it's really important that you mark the solution there with the dot is going to be there at negative 4, 3. So at negative 4, 3 is my solution. So the next question, question number 5, asks you to solve using the substitution method. So it's asking you to demonstrate your knowledge of the substitution method. So the substitution method means that I'm going to combine these two equations, and I'm going to do it by putting one equation into the other equation. So I know that x plus y is going to equal 42, and they also tell me that y is equal to 5x. Now, when I'm doing the substitution method, I want to get one variable all by itself. And so I've got that right here with this y equals 5x. This allows me to do that substitution. So what I'm going to do is I'm going to rewrite this first equation, but I'm going to replace y with 5x. So I'm going to replace y with 5x. So that's going to become x plus y, which we're going to use 5x, is equal to 42. And so now I've got one variable, I've got one equation, I can solve that. So this is going to be 6x is equal to 42, which means if I divide both sides by 6, that x is going to be 7. Now, I know the x value. I still need to find the y value. But I know from right here, right, from this second equation, that y is equal to 5x. So y is going to be 5 times 7. Y is going to be equal to 35. So my coordinate, my solution here is going to be the point 7, 35. Question 6, they're asking you to do the substitution method as well. So here I have x plus 5y is equal to 53, and I have 4x plus y is equal to 41. So again, I need to use the substitution method. So the substitution method, I need to get one variable all by itself. And so in this equation, it'd be pretty easy to get the x all by itself. In this equation, it would be pretty easy to get the y all by itself. And it doesn't matter which one I do, I just pick one and see. So I'm going to choose the x one here. So I'm going to subtract 5y from both sides. And what I end up here is x is equal to negative 5y plus 53. Okay, so this allows me to do this substitution. So I'm going to rewrite this equation, but instead of x, I'm going to write negative 5y plus 53. So over here, I'm going to have 4 times x, but I'm going to write negative 5y plus 53 plus y is equal to 41. And now I can just go through and solve this equation. Okay, I'm going to zoom in a little bit closer here so you can see that. Okay, so I'll go ahead and distribute here. So 4 times negative 5 is going to be negative 20y. And then 4 times 53, well, 4 times 50 is 200, and 4 times 3 is 12, so that's going to be 212, plus y is equal to 41. I can combine my like terms here, so I've got negative 20y plus y, that's going to give me negative 19y, plus 212 is equal to 41. I'm going to subtract 212 from both sides. Okay, and let's see, 212 minus 41 is going to be 1. We'll borrow there. That's going to be 11. It's going to be 7. 171. So that'll be negative 171. So I get negative 17y is equal to negative 171. Okay, so now I just need to divide both sides by negative 17, and I hope that's going to go in there evenly. I don't think that it will. I'm going to use Desmos here, and so switch to Desmos here. Oops. Okay, so I'm going to do negative 171 divided by negative 17, oops, divided by negative 17, and it gives me that weird number. So that's kind of a weird number. I was hoping that that would work out a little bit nicer, but I want to go back and just kind of check my math here and make sure that I did this correctly. It's 212 plus y is 4, it's 20, 19. 41. Oh, this is 19. There, see, you know, I made a mistake there. So this is negative 19. There we go. All right, so let's try that. Let's try it instead of 17. Let's put 19 in there, and we'll get, yeah, that's a much better number. Okay, so that's going to equal positive 9. So y is going to equal positive 9. Okay. Okay. Now we've got y, we need to figure out what x is. So if I go over here, I know that x is equal to negative 5 times y, which is 9, plus 53. So my x is going to be negative 45 plus 53, which is going to be 8. So x value is going to be 8. So my solution here is going to be the 8, 9. Okay, and if I wanted to check that, right, and that's probably a good idea. I made some mistakes here. I want to go back and just check that real quick. The way that I can check that is I can plug 8 and 9 into this equation, right, and see that that works. So 4 times 8 plus 9 should equal 41. 8 times 4 is 32 plus 9 equals 41. That's true. Okay, so I'm pretty confident that my answer is correct here. So I'm going to put an 8 and 9. Okay, next question, question number 7. So again, we're using substitution. So we have x plus 2y is equal to 29. And they give us that y is 5x minus 35. Now this is all set up for substitution. We've got one variable all by itself, so we can just go right ahead and substitute that. We're going to replace y with 5x minus 35. So x plus 2 times y, which is 5x minus 35, is equal to 29. I'll go ahead and distribute here. So I've got x plus 10x minus 70 equals 29. And so I've got 11x minus 70 is 29. And so I'll add 70 to both sides. 11x is equal to 99. That tells me that x has got to be 9. Okay. If x is 9, I know that y is equal to 5 times that minus 35. And so that's going to be 45 minus 35. Y is going to be 10. So my solution is the point 9, 10. And again, I can check that. I can plug those numbers into that first equation. So if I did 9 plus 2 times 10 is 29, I can see that that's going to work out. So there's a nice little check there. So here's my solution right there is 9, 10. Question number 8 talks about using the addition method. The addition method is also called the elimination method. And what that means is that we need to combine these equations in a way that one of the variables goes away. And so what we're looking for is to be able to multiply one of these equations so that the variables are the same, right? The coefficients are the same, but opposite signs. So if this is a 4y, I'd like to make that a negative 4y. If this was a negative 7, I'd like to make this a negative 7 or some multiple of that, right? But the easiest thing to do is to take this equation and multiply it by negative 4. And that's going to give us a negative 4y there. So I'm going to do that right over here. Negative 7x plus y is equal to negative 13. I'm going to take that whole equation and multiply it by negative 4. So down below here, this is going to be negative 4 times negative 7 is going to be 28x. Negative 4 times y is negative 4y. That's what we were trying to create there. And negative 4 times 13, well, 3 times 4 is 40. 4 times 10 is 40. 4 times 3 is 12. 40 plus 12 is 52. And that's going to be negative times negative is positive. There we go. Okay, so now this is the situation that we're trying to create here. We're trying to create equal and opposite. So we have a positive 4y and a negative 4y. And what I can do now is just add these two equations together. And so 28 plus 3 gives me 31x. Positive 4y minus 4y is 0. And then that's going to be 73. And again, I just want to double check my math here, make sure I'm doing this right. Positive 28, negative 4y, 40, 52, 73. Okay, let's check and see. So if we have x is going to be 73 over 31. So let's try that, 73 over 31. And that's kind of a weird number. So I'm a little suspect here that maybe I'm not doing something right. So I'm going to want to check my work here and just make sure I've got this right. And I do. I see the problem. When I wrote this problem down, I wrote it down incorrectly. So that should be a negative 21 and not a positive 21. Okay, so that's going to change my math here. This 31 is still going to be the same. Okay, but this here is going to be positive 31. Okay, so that makes that a little bit better. So the importance of showing your work, writing down your work, so that when you make those mistakes, you have a place to go back to and see what's going on. So I have 31x is equal to 31, which means that x has to be 1. Okay, so I'm happier with that answer. Now I have to figure out what y is. And so I can go and plug 1 into any one of these equations and see what I get. And so I'm just going to go ahead and plug it into, let's go into the first equation. So I'm going to have negative 7x, which is 1, plus y is equal to negative 13. And so I get negative 7 plus y is negative 13. Add 7 to both sides. So I get y is equal to negative 6. So my point would be 1, negative 6. And again, I can check that by plugging that into one of the other equations. So if I check that, if I go into the second equation, 3 times 1 plus 4 times negative 6 should be negative 21. And so I've got 3 plus negative 24 is negative 21. That's true. So that's a check. So there's my solution there. It's 1, negative 6. Okay, so question number 9. They just simply ask us to solve this equation. They don't say how, so it's up to us to decide how we want to do this. We could use elimination, we could use substitution, we could even graph it. So I'm going to look at this equation and see if there's an easy way that I can do one of these. If I multiplied the second equation by 4, I would get a positive 4y and a negative 4y. And so that might be an easy thing to do. I could also solve this for y, right? And then use substitution. But I've got this negative y here. And so I'd have to do a couple of operations to get that by itself. So I think it's going to be easier if I just do the elimination method. So this is problem 9. We have negative 2x plus 4y is equal to 2. And we've got negative 3x minus y is equal to negative 4. So I want to turn this into a negative 4, right? Turn that y into a negative 4y. So I'm going to multiply everything by 4. So my first equation is going to stay the same. My second equation is going to be 4 times, so 4 times negative 3 gives me negative 12x. 4 times negative y gives me negative 4y. And 4 times negative 4 gives me negative 16. Okay, so this creates that situation that I'm looking for, positive 4y and a negative 4y. Now I can just combine these two equations. So I get negative 14x is equal to, those go away, negative 14. And so I know that x has got to be 1. So I can take that x, I can plug it into any one of these equations here to figure out what y is. I'm going to go ahead and plug it into this equation right here. So I'm going to use negative 3 times 1 minus y is equal to negative 4. So that's going to be negative 3 minus y is equal to negative 4. Add 3 to both sides. I get negative y is equal to negative 1. If negative y is negative 1, then y has to be positive 1. So my solution here is going to be the coordinate 1, 1. And again, I can check that by plugging it into any one of these other equations. If I plug it into the top here, I'd have negative 2 plus 4 is positive 2. So I can just mentally check that. And so I'm pretty confident that that works. So this is 1, and this is 1. Okay, problem number 10. Again, they ask us to just solve this. They actually say to solve it using elimination. So we'll go ahead and do that. Minus 3x plus 4y is equal to negative 17. And we've got negative 4x minus 4y is equal to negative 4. And I notice that I'm all set up for elimination. I have a positive 4y and a negative 4y. And so I can just add those together. There's no need to multiply anything. And so I get negative 7x, those go away, is equal to negative 21. And if I divide both sides by negative 7, I get x is equal to positive 3. And so I can take that value, plug it into any one of the other equations. I'll just go to the first one, minus 3x plus 3 times 3 plus 4 times y should be negative 17. And so I get negative 9 plus 4y is equal to negative 17. Add 9 to both sides. I get 4y is equal to negative 8. And so y has to be negative 2. So my solution there is 3, negative 2. And again, I can check that by plugging it into the second equation. This would be negative 12. This would be positive 8. Negative 12 plus 8 is negative 4. So I can see that that's going to work out. So they ask you to solve this by graphing, but you also have an instruction up here to solve it using any method. So you can graph this if you wanted to, or you could go ahead and just solve it. So a couple ways of doing that. Let's actually do it by graphing, and let's just see how that works out. So on number 11, I've got the equation y plus 6x is equal to negative 16, and I've got 2y is equal to negative 12x minus 32. Okay. So I'm just going to go ahead and graph this. So I'll create two equations here. So I've got y plus 6x is equal to negative 16. So there's the first line. The second line is going to be 2y is equal to negative 12x minus 32. And if I look at that, right, do you see what happened there, right? Those equations, those lines are sitting right on top of each other. They actually represent the same line. And I can kind of see this, right? If I were to take this first equation, or sorry, the second equation and divide everything by 2, I would get y is equal to negative 6x minus 32, which is very similar to this, right? You could rearrange those equations and show that they're actually the same, that they're equivalent equations. All right. So that's probably the easiest way to do that. There is another way you can do that, and that is using either elimination or substitution. And so I'm going to do that real quick just to kind of show you how that works out. So if I did, let's say I used substitution here. Okay, and what I'm going to do is I'm just going to take this second equation and I'm going to divide everything by 2. Divide that by 2, divide that by 2, divide that by 2. And that will get y all by itself. And so this will be y is equal to negative 6x minus 16. Now if I take this second equation here and I substitute it back into here, so I replace y with negative 6y plus 6 minus 16, you'll see what happens here. And so I'm going to replace y, so y is negative 6x minus 16 plus 6x is equal to negative 16. And when I combine my like terms there, my x terms go away, and I'm left with negative 16 is equal to negative 16. Okay, all my variables went away, and I'm left with a true statement. So that is true. So this means that there is an infinite number of solutions. Okay. You could also say that the solutions are all of the real numbers. Now, they give you some instructions here. They say, enter the solution set in the boxes below. If the lines are parallel, right, the parallel means that there's no solution, we would say D and E into each box. If the lines are coincident, right, meaning that they sit on top of each other, there's an infinite number of solutions, we're going to type infinity, and the way we type infinity is 2 lowercase o's, so OO and OO. Okay, so there's an infinite number of x's and y's that we can do there. Question 12 asks you to do a similar thing. You can solve this using any method you want. Again, you could graph this, but let's take a look here. Y minus x equals 4, and then we've got y is equal to x plus 7. Okay, now this is all set up for substitution. It's all ready to go. I can just take the second equation, y, and replace y with x plus 7. So that's what I'm going to do. I'm going to take a y here, replace it with x plus 7, minus x is equal to 4. Okay, so I use substitution here. And what I see here is my x's cancel each other out. X minus x is 0, and so I've got 7 is equal to 4. That is not true. Okay, 7 does not equal 4. So that means that there are no solutions to this. This also means that those two lines are parallel and they don't actually ever touch. And so let's take a look at that and just verify that that's the case. So if I put in the first equation, y minus x equals 4, and the second equation, y equals x plus 7. Okay. I can see that there, right? These lines have the same slope, but different y-intercepts, which means that they'll just run parallel to each other, like a set of railroad tracks, right? They'll never, ever cross each other. Okay, so there is no solution to this problem. So it tells us again here, if the lines are parallel, we're going to enter D and E for does not exist. So that's what we're going to put in D and E, and D and E. Okay, the next set of questions here are word problems, some story problems, and so I know that these are challenging for a lot of people. The tricky part is to figure out, what the variables are. What are you going to use for variables, and then to write some equations for this. Okay, so number 13. We're going to read through this first. So a man has 34 coins in his pocket, all of which are dimes and quarters. And the total value of his change is 610 cents. How many dimes and how many quarters does he have? So you notice the question here is how many dimes and how many quarters, and the answers here are going to be the number of dimes and the number of quarters. Those are going to be my variables. So I'm going to say that D represents the number of dimes, and that Q represents the number of quarters. Okay? Now, so that helps me kind of get straight in my head that these are the things that I'm looking for. Okay. Now, I'm going to go back through and read this and kind of look at some of this information. A man has 34 coins, all of which are dimes and quarters. Okay, so D represents the number of dimes, Q represents the number of quarters, and this is telling me if I add all those together, I'll get a total of 34 coins. All right, so how do I write that? Well, this is the number of dimes plus the number of quarters added together is 34 coins altogether. So there's one equation. Okay, my second equation talks about the value, right? The value of the change. And so if I looked at the value of the dimes and the value of the quarters, the total of that would be 610. So I have to think about how much is a dime worth. Well, a dime is worth 10 cents. So 10 cents for every dime and 25 cents for every quarter. So this number represents the value of the dimes. This number represents the value of the quarters. And we know that the total value is 610 cents. Now, if they would have said the total value was $6.10, I would have written these numbers differently. I would have wrote 6.10 and 0.1 and 0.25. to represent, dollars, okay? And now they're just asking us to solve this, okay? So I can solve this in any method I want to. I could graph these, right? I could say X is dimes and Y is quarters, and I could graph those. But this is really, it's not too bad. This is set up pretty easily for either elimination or substitution, okay? I could easily multiply this top equation by -10, or I could multiply this top equation by -25, or I could subtract Q and solve for D, or I could subtract D and solve for Q. So there's lots of different options available to you to solve this. I'm going to go ahead, I'm just going to go ahead and multiply this top equation by -10. And so if I rewrite this down below here, this becomes -10D minus 10Q is equal to -340. Okay, so I'm going to write that down there. Now, if I combine these two equations together now, the dimes part goes away. 25 minus 10 gives me 15. And 340 minus 610 is going to be, is at 270. 270. And again, if I'm not sure about that, grab a calculator and do that, right? So 610 minus 340 is 270. Okay. Then my last step, I'm going to divide that by 15. And I'm going to use a calculator for that too. 270 divided by 15 is 18, and so I know that this person has 18 quarters. All right, if they have 18 quarters, I know that they have a total of 34 quarters. So I know that the dimes plus 18 quarters is going to be 34. So my dimes are going to be 34 minus 18, which I believe is 16. So the number of dimes is going to be 16. And then just kind of as a sanity check, right, I know that 15 quarters is 270. I know that 10 dimes, right, 10 cents per dime, let's do that again. 10 cents per dime is going to be 160. And then 25 cents per quarter, so if I said it has 18 quarters, that would be 25 times 18. That's going to give me $4.50. And so 160 plus 450 should equal 610, and it does. So there's my check step there, okay? So I know that he's got 16 dimes and 18 quarters. So back here, the number of dimes is equal to 16, and the number of quarters is equal to 18. Question 14, they're asking you about phone systems, right? Cell phone plans. And so, again, we're just going to read through here and try to figure out a way to represent this, okay? So they give us some information about some cell phone plans, and then they ask you about the number of minutes you would have to use in a month for the second plan to be preferable. Okay, now we have to kind of interpret that a little bit, right? What does preferable mean? Well, preferable means that it costs less. So we're talking about the number of minutes and we're talking about the cost. Okay, so we're going to look at the number of minutes and we're going to look at how much that cost, and then we're going to compare those. All right, so on number 14 here, I'm going to use C as the cost per month for one of the phone plans, and then M is going to be the number of minutes per month. Okay, so let's start comparing these phone plans. So for the first plan, the cost, right, the total cost is going to be 23 cents a minute. So 0.23 cents for every minute, so times M. Okay, and there's no other fees or anything that go along with that. So that's the first plan. The second plan, to find the total cost, it's going to be only 12 cents a minute, but there's an additional cost of $49.95. Okay? And so what we want to do is we want to figure out, when will they be equal, right? When will the two plans be equal to each other? It looks like the second plan, if I use more minutes, it will probably cost me less, but let's see. So this is all set up for substitution. I've got two variables already all by themselves, and so I can just set these equal to each other. I can replace this C with 0.23 m. So 0.23 m is equal to 0.12 m plus 49.95. So I'll subtract the m from that side, and so I end up with that's going to be 11, right? 0.11 m is equal to, those cancel out, 49.95. So I'll jump back to my calculator here, clean this up, and so I've got the number of minutes where they'll be equal will be 49.95 divided by 11 cents. So 49.95 divided by 0.1. So that gives me 454.090909. Okay, so that's it. 454.0909. All right, and it asks you to round it up to the nearest whole minute. So the nearest whole minute would be 454 minutes. Okay, so at 454 minutes, those two plans would be pretty much the same. If I had more than 454 minutes, then I'd be better off paying for less per minute. Okay, so the second plan would be, right? So they want to know how many minutes would you have to use in order for the second plan to be preferable. So that's going to be 454 minutes. What did I do wrong there? Let's go through this and check again. 12 cents a minute. Okay, I subtracted there. 49.95 divided by 11, 454.09. 454.0909. Let's try this again. 23 cents a minute. Second plan to be preferable. Oh, you'd have to use more than 454 minutes. So it'd be 455 minutes would be what we would need for the second plan to be preferable. There we go. Okay, so the math was right. It's the interpretation of the question that I had a little bit off. All right, last problem here. They have a situation here. They give you two numbers, and they tell you some information about those numbers. So let's look here. So they give us two numbers, and they say that they want x to be the large number and y to be the small number. Okay. They say the sum of the two numbers is 45. And so they ask you to write an equation for that sentence. The sum of two numbers is 45. Well, the sum means add. My two numbers are x and y, so that's going to be x plus y is equal to 45. Okay, so there's my first equation. X plus y equals 45. The second equation, the difference of the two numbers is 31. So difference, okay? And I end up with a positive number, so I know I'm going to subtract, right, the small number from the big number. So I'm going to take the big number and I'm going to subtract the small number, and I'm going to end up with 31. So there's going to be my second equation. X minus y equals 31. And then they want you to solve that. All right. Now, if I look at this system of equations right here, right, it's perfectly set up for elimination of a positive y and a negative y. If I add these two together, I get 2x is equal to 76. And if I divide both sides by 2, I know that x is going to be 38. Okay, and I also know that x minus y is 31, so 38 minus y is going to be 31. That tells me that y has to be 7. Okay, so the larger number should be 38, and the smaller number should be 7. Okay. Now, I should check those and make sure that if I add those together, they should be 45, and they are. All right, so go ahead and submit that. It looks like we're okay there. Okay, so that's the last problem on that practice test. So I hope this is helpful. Please let me know if you have any questions.